Welcome back to the Deep Dive. If you've been tracking our analysis of the next, say, half decade in technology, we're past talking about just clever prototypes now. We've really been focusing on these massive shifts, the 8 critical developments that we think will move AI deployment from basic proof of concept stuff into real infrastructure level foundations. For the whole global economy, really. We've charted 7 paths already, covered a lot of ground foundation model as a service, those regulatory compliant explained by design models, even AI-driven drug discovery, quite a range. But today, we're hitting topic number 8. And honestly, for anyone listening who works in a regulated industry, or frankly, just cares about who owns their personal data, well, this one might be the most critical. Federated and secure multi-party AI collaboration networks.
It's quite a name.
Really is a mouthful. Let's maybe just call them secure consortia AI. Because the core idea, it feels genuinely revolutionary.
That's a good shorthand. Yeah, absolutely right. When we talk about secure consortia AI, we're essentially describing these organized groups, consortia of different organizations, and they've basically figured out how to co-train these incredibly powerful machine learning models using data that's, spread all over the place, globally distributed. And the key is how they do it, using really sophisticated cryptographic techniques and things like differential privacy. So our mission today really is to give you the shortcut, help you understand the specific mechanics, how this sort of privacy magic works, how it solves these trust issues that have plagued collaboration for decades, and crucially, why these secure networks are really projected to fundamentally reshape industry, public policy, maybe even the personalized services you're using every single day.
Okay, let's definitely unpack this. It feels like you're describing solving what I always think of as the ultimate privacy paradox. The goal is getting massive industry-wide intelligence, right?
Yeah.
But without any single player having to expose their really sensitive stuff, whether that's secret manufacturing formulas or, personal patient health data. How is that even possible? What's the tech foundation for this secure consortia AI?
Well, the foundation basically relies on integrating 2 pretty advanced concepts. Think of them as acting like a cryptographic shield. We're combining secure aggregation that protects individual inputs and something called homomorphic encryption.
Homomorphic encryption.
Yeah.
Okay, that sounds like pure science fiction.
It does a bit.
Can you give us maybe an analogy? How can you do math, do computation on data that's still encrypted? It just seems impossible on the face of it.
Okay, let's try this. Think of it like a really smart locked vault. You've got data inside, maybe 2 numbers you want to add together. You, the owner, put the numbers in the vault, you lock it, and you send that locked vault to, say, a central server. Okay. Now, the server, through some very clever, specially designed mechanisms, can actually perform the addition while the vault stays locked.
Seriously?
Yes. The server only ever sees the encrypted inputs. It does the calculation on the encrypted stuff, and then it sends the encrypted result back to you. And only you, because you have the key, can actually unlock the vault and see the final sum. The server. It never saw the original numbers at all.
Wow. Okay, that's a powerful visualization. The computation happens, but the underlying data stays completely hidden, obscure. So now layer in the other piece you mentioned, secure aggregation. That's the part that ensures, if you have 50 hospitals sending in their individual encrypted model updates, no single hospital's contribution can be snooped on, not even by the central server coordinating things.
Precisely. That's exactly it. Secure aggregation basically sets a rule. It requires a minimum number of participants, of clients, to contribute their encrypted updates before those individual bits can be combined, aggregated into the final improved global model. So if one hospital drops out unexpectedly, or maybe a malicious actor tries to eavesdrop somehow, well, those individual model updates just stay encrypted. They're effectively useless on their own until that required quorum, that minimum number, is reached and they all get properly combined.
And that is the core principle, isn't it? The thing that gives these federated networks their power and also their ability to scale. Multiple parties working together, training powerful ML models without ever needing to directly share their sensitive raw data.
That's the critical pivot, absolutely. The data stays put, it stays localized on the individual user's device or safe within the organization's own secure data silos. So instead of trying to move, terabytes upon terabytes of raw patient data or proprietary manufacturing secrets to some central cloud.
Which is always the risky part.
Exactly. Instead, you only share these encrypted parameters. It's essentially a small aggregated summary of what the model learned from the local data, not the data itself.
It just fundamentally flips the script.
Yeah.
You're moving the computation to the data rather than trying to move all that heavy, risky data to the computation hub.
Precisely. And that right there solves the enormous trust deficit that's really held back collaborative AI until now.
Okay, so here's where the implications get really, really exciting for me.
Yep.
Because organizations can co-train models on this shared encrypted data without exposing their raw records. Well, it enables genuine industry-wide intelligence, right? While simultaneously preserving privacy for every single individual and organization involved. It just feels like a true sea change in how competitors might actually coexist, even collaborate.
Oh, it unlocks sectors that have been, frankly, paralyzed by regulation and, fierce competition. We really see the impact as twofold. First, like you said, you get these immense shared insights across an entire industry. Think about a consortium of rival banks, for instance.
Hey.
They could collaborate to train a single, really powerful, unified fraud detection model. Now, every single bank benefits from the collective knowledge, right? All the latest fraud patterns swirling around. Yet, and this is key, their individual customer transactions, their own proprietary detection methods, those are never exposed to their competitors.
Which means the entire financial system just gets smarter, more resilient against attacks, and faster than any single bank could possibly achieve on its own.
Exactly. And the second big impact is, well, it's competitive, but in a different way. Companies can collectively raise the sort of foundational baseline of AI capability for their whole sector, improving things like supply chain resilience or safety protocols or maybe baseline diagnostic accuracy in healthcare. But crucially, they still preserve the unique proprietary data that gives them their individual business edge. So, everyone gets the benefit of a rising tide lifting all boats, but they each get to keep their own unique speedboat, so to speak.
That's a great analogy, the rising tide and the speedboat.
So if we look at the timeline the sources suggest, we seem to be right in the middle of this crucial pilot consortia stage. That's projected roughly 2024 through 2026. This is really where organizations are, building trust, working out those early technical kinks together.
Right, the proving ground. And what about the near-term future? When does this really start to hit full speed?
Well, the projection is that by about 2027 to 2029, these secure consortia AI systems will really move into being fully functional cross-industry ecosystems. That's when we expect to start seeing true, widespread industry transformation, particularly in areas like, say, personalized medicine and advanced smart manufacturing.
Okay, it's clear how this can theoretically work, but let's talk practice. Where are we actually seeing this kind of intelligence land, and how will it impact us, the listeners? Our sources map out how these federated networks are set to transform whole industries by enabling this deep data-driven innovation, but while rigorously maintaining privacy.
Yeah, let's get concrete. A really obvious fit is secure cybersecurity.
Makes sense.
Think about government entities, large corporations, maybe critical infrastructure providers. They can collaborate to train these highly robust AI models for detecting network intrusions, malware, other cyber threats. And because the training is happening across potentially thousands of decentralized distinct networks, the final global model becomes far more resilient. It's much harder to fool, more robust against any single point of failure or a targeted attack. It's almost like crowdsourcing security intelligence, but on a secure, decentralized ledger.
Yeah, that inherent distribution makes the whole system stronger. Okay, moving into the industrial world, you mentioned predictive maintenance earlier. That seems like a huge one.
Absolutely huge. I mean, think about the sheer volume of data generated by IoT sensors, devices in manufacturing plants or aviation or energy grids. These devices can train AI models right there, locally, on their real-time performance data. This allows for extremely accurate prediction of potential equipment failures, which lets companies optimize maintenance schedules, reduce really costly downtime, and crucially, they do all this without ever sending that highly sensitive operational data, basically the heartbeat of their factory, outside their own secure environment.
Okay, and then there's the really personal application, personalized medicine. You mentioned my wearable device or maybe a health app. It trains on my specific data.
Right, on your individual data to offer potentially highly accurate, personalized health insights or recommendations. And that sensitive data, it might never leave your phone or at least your secure personal cloud environment.
That's compelling.
Yes. And here's the sort of dual benefit again. That same local training, done privately on your device, contributes a tiny encrypted piece, remember, just the parameters to broader global models. These global models then improve medical care, diagnostics, or research for everyone. So your personal health data can actually help solve big global medical puzzles, but without you ever having to sign away your privacy rights explicitly.
And we're already seeing shades of this now, right?
Oh, absolutely. Companies like Google and Apple, they already use these kinds of federated learning principles today, right now, to improve features you use constantly, like predictive text on your keyboard or voice recognition. The model learns your specific way of speaking, your unique language habits, but without ever needing to upload your actual private texts or voice recordings to their central servers. The learning happens locally.
That scalability aspect is key. But I have to ask, if the data doesn't all come together in one place, doesn't the model quality suffer somehow? Isn't there a trade-off in fidelity by not having all that raw information centrally located?
Yeah, that's a really important question, and it's precisely the challenge this whole system is designed to overcome, or at least manage very carefully. See, because you aren't moving those massive amounts of raw data to one central spot, you actually eliminate the single biggest bottleneck in traditional large-scale AI, which is usually that massive centralized data center and the bandwidth to feed it. Now, you're right, there are definitely quality challenges related to data heterogeneity, basically data looking different across different sources, and we should definitely touch on that. But the core advantage here is the distribution. This decentralized architecture allows the training workload itself to be spread out across potentially millions of devices, or clients as they're called. So the model gets the benefit of sheer volume learning from millions of users or devices, but without the massive liability and cost of centralizing all that data. It scales horizontally. You can add more participants much more easily without a proportional explosion in central infrastructure costs.
Okay, that sounds incredibly promising. But, as with any cutting-edge tech, especially one dealing with sensitive information and complex cryptography, there've got to be some significant hurdles, right? Technical, legal. We absolutely need the balanced view here. What are the real risks? What stands in the way of this technology really hitting its full potential?
Oh, definitely. There are substantial challenges. Let's start with the technical ones. The first big one is simply communication overhead. The very thing that makes these systems secure, all those layered cryptographic protocols, the secure aggregation steps, well, that adds latency. It takes time.
Right. The decryption isn't instant.
Exactly. Encrypting the updates, securely aggregating them from potentially millions of sources, maybe decrypting parts of the result, it all adds up. If you have millions of devices trying to send updates back frequently, that secure protocol overhead can become, well, debilitating for performance. So finding ways to make the communication more efficient, maybe clever compression techniques for these encrypted updates, that's a really serious research priority right now.
And even with all the encryption and the distributed setup, secure consortia AI isn't totally impenetrable to bad actors, is it?
No, that's a critical point. It significantly enhances privacy and security compared to centralizing raw data, but it doesn't magically solve every single security problem. Our sources point to two major systemic vulnerabilities, which are actually kind of classic adversarial attacks adapted for this new landscape. The first is something called model poisoning.
Okay, what's that?
It's basically where a malicious client, one participant in the network, intentionally introduces bad data, corrupted updates, maybe subtly biased information. Their goal is to skew the results of the final global model. So imagine a rival hospital in that consortium we talked about. If they started deliberately submitting slightly incorrect diagnostic updates over time, it could subtly degrade the overall accuracy of the collective model for everyone.
Sneaky. And potentially hard to detect if it's subtle enough.
Very hard. And then there's the other one, which frankly sounds a bit more frightening, gradient leakage.
Gradient leakage.
Mm-hmm.
Okay, even if the raw data itself is encrypted and stays local, you're saying these encrypted updates, the gradients can somehow leak information.
Potentially, yes. That's the concern. Gradient linkage is essentially like trying to read the residual smoke signals left behind by the raw data, even after it's been encrypted and aggregated locally. These gradients, remember, are small pieces of information about how the local model changed based on the local data. Under certain circumstances, it's theoretically possible, though difficult to mathematically analyze these gradients and potentially infer or even reconstruct sensitive details about the original training data they came from.
Wow.
Now, researchers are constantly developing stronger cryptographic techniques and defenses, like adding noise to prevent this. But it's definitely a kind of ongoing arms race between the privacy techniques and the potential attacks.
And then just the messy reality of using data from all over the world, right? Different sources.
Yes, the data quality challenge. It's enormous, mainly because of what's called data heterogeneity.
Meaning the data just isn't consistent?
Exactly. When you're dealing with, say, hundreds of different companies or hospitals or even individual users' devices, Their equipment might be different. Their data collection protocols vary. Even the underlying statistical distribution of their data sets can be significantly different. If one manufacturing plant is using sensors from the 1990s and another has cutting-edge 2024 sensors, the data they feed into their local model training is going to be wildly different, heterogeneous. And this lack of uniformity, this inconsistency, can introduce serious systemic biases or inaccuracies into the final global model. That's a major concern for fairness and reliability, especially in high-stakes fields like finance or medical diagnostics.
Okay, and finally, we absolutely have to talk about the legal side. You mentioned consortia, collaboration, but who owns the result? What about the intellectual property?
Yeah, this is arguably the biggest regulatory hurdle, maybe even more than the technical ones in some sectors. Defining liability and, crucially, intellectual property ownership for these jointly trained models. It remains a massive challenge. Just imagine, say, 3 pharmaceutical companies. They co-train a sophisticated model to screen for potential new drug compounds. Okay?
Right.
That shared model generates a revolutionary insight. It points towards a new molecular structure, leads to a breakthrough patented drug. Who owns that patent?
Good question.
Is it the company that happened to contribute the most data points to that specific insight? Is it the company that maybe developed the final proprietary algorithm based on the model's insight? Or does a consortium as a whole own it? How are profits shared? What if the model makes a mistake leading to harm? Who is liable? These questions require really solid, transparent, upfront legal agreements and frameworks before heavily regulated sectors, especially healthcare and finance, can fully embrace secure consortia AI at a massive scale.
Right. So bringing it all together then. If we pull back from the weeds, what's the critical advancement here? What's the main thing we need to remember about this shift?
I think the synthesis, the big picture, is that secure consortia AI really marks a profound advancement because it helps us move past that awful trade-off we always faced before. It allows for the creation of AI systems that are both incredibly intelligent because they can learn from massive amounts of distributed data and rigorously mindful of personal and organizational privacy thanks to all that cryptographic protection. This technology isn't just, innovative. It feels absolutely critical for sectors like finance, health, national security, places where data sharing has historically been almost impossible because of the risks and the legal liability involved.
So it unlocks collaboration where it was stuck before.
Exactly. Now, the future outlook, how fast this spreads, that depends heavily on continued technical improvements. We need progress in making those cryptographic methods faster, more efficient. We need better, lower latency communication methods for these updates. And probably developing clever hybrid approaches, maybe combining some speed benefits of traditional AI with the core security of federated learning. Those advancements will really influence the extent we see practical, large-scale implementation over the next, say, 5 years or so.
It really feels like it could change the very definition of industry collaboration. And that, I think, brings us perfectly to our final provocative thought for you, the listener, to mull over based on everything we've discussed. If organizations can achieve these massive industry-wide competitive advantages, things like better medical diagnostics, stronger cybersecurity, more optimized global logistics by sharing only these encrypted model parameters, these learnings, well, how might our traditional concept of proprietary corporate data need to fundamentally change? Think about it. If you no longer have to keep the learning locked away just to keep the raw data private, maybe the whole competitive game shifts. Maybe it moves away from just hoarding data towards mastering the art of secure, effective collaboration.
Yeah, that's a truly fascinating potential shift, isn't it? One to definitely watch as these ecosystems start to solidify over the next few years.
Absolutely. Well, that's our deep dive on federated and secure multi-party AI collaboration networks, or secure consortia AI for short. We'll see you next time as we continue exploring the developments that are truly reshaping our world.
Until next time, keep exploring, keep questioning, and keep diving deep. Thank you for listening to today's podcast. Please feel free to click on the link in the description below to discover more podcasts.